Hello students, this is my third video on ellipse. I hope you have watched my previous videos on ellipse. Those were ellipse 1 and ellipse 2. If not, then go through those videos. The link is in description box. Here I am with some super shortcuts. This is the first type of ellipse when A is greater than B. In this case, eccentricity is root of 1 minus b square by a square. Foci here are plus minus ae comma 0. Major axis length is here 2a and minor axis 2b. Directrices, equation of directrices are x equal to plus minus a by e. Just a quick recap. But in this case, the formula for eccentricity is root of 1 minus a square by b square or b square minus a square by b square. In this case, just replace x coordinate by y coordinate, a by b, x by y. So 0 comma plus minus be are the foci. Major axis length is here 2b. Minor axis length is here 2a. Equation of directrices, y is equal to plus minus p by e. Length of LR here in first type is 2b square by a, but in this case length of LR is 2a square by b. So, and these two vertices both have center at origin. Center of both the ellipse, that is for this and for this, both have center at origin. Now here we have special form. In this case, if the center of the ellipse is at point h comma k and the directions of the x's are parallel to the x-axis, then its equation is x minus h whole square by a square plus y minus k whole square by b square equal to 1. Now here, in this question, if you get this type of ellipse, you have to reduce it into the special form, that is x minus h whole square by a square, y minus k whole square by b square equal to 1. But in case, if you have to find eccentricity, then there is a shortcut. What we do here, no matter whatever ellipse is this, the formula for eccentricity is 1 minus, and the coefficient of x square is here 1, the coefficient of y square is here 2. You take the smaller one in numerator and the greater one in denominator, that is, we take a square here, we take b square here 1 and a square here 2, and just we get the eccentricity, that is 1 by root 2. So what is my shortcut? You just write root of 1 minus the smaller coefficient is in numerator and the greater one is in denominator, the coefficient of x square and the coefficient of y square. So this is what the eccentricity of this type of ellipse. Further, if you have to find center, so in that case you just differentiate this equation 1 with respect to x and just taking y as a constant. So what we get here, 2x, here derivative is 0, derivative of minus 2x is minus 2, and rest are 0. Why? Because y is here constant, so derivative of 12y is 0, derivative of 10 is 0. So I have differentiated equation 1 with respect to x. So here I get x equal to 1. And further again, I have to differentiate this equation 1 with respect to y, taking x as a constant. So what we get, derivative is here 0. What I get here, 4y. Here I get 0 and here I get 12 and here I get 0. So this is 4y minus 12 equal to 0. So y is here 3. So now my center is here 1, 3. Now I have to reduce this equation in this form. So now what we do here, I'm just rewriting the equation. My equation is here x square plus 2y square minus 2x plus 12y plus 10 equal to 0. As we have obtained center here, so I just write here, I'm just reducing this equation in this form. So I just replace this by a complete square, that is x minus, here I put the x coordinate of center. And if coefficient of y square is 1, then just replace that by y minus the coordinate of y coordinate of center there. But since the coefficient of y square is here 2, so you take just 2 common here and just put the y coordinate of the center here, so that is y minus 3 whole square. Now just we have to balance the equation. What I get from here, if I open this, then this comes out to be x square minus 2x, that means I get these two terms, x square minus 2x, but I get here plus 1. So just to balance that, I write here minus 1. In this case, if I use the identity, this comes out to be y square plus 9 minus 6y. So y square is 2y square and minus 6y, or that comes out to be here. So my center is here. No, there is a problem. This y is here minus 3. So I just like this. Now, what I do, the identity is y square plus 9 plus 6y. And if I open that bracket, then y square comes out to be 2y square and 6y. After multiplying by 2, I get 12y. So we are left here with only 9, and after opening the bracket, I get 18. And in order to balance that, I write here minus 18. And rest what I have to write this 10 over here, this 10 here. Now what I get here, this comes out to be x minus 1 whole square to y plus 3 whole square and minus 19 plus 10. So this is minus 9, and if I take this to this side, now just I have to reduce it into this form, that is x minus h whole square by a square y minus k whole square by b square equal to 1. So this comes out to be, if I divide left hand side by 9, so this comes out to be x minus 1 whole square by 9 to y minus of minus 3 whole square by 9 equal to 1. Further reducing it to standard form, so I get this as my equation of ellipse, where a square comes out to be 9. So a square is here 9. This is my b square. Now whatever I have to find, I can find now. Now suppose I have to find foci. So as we know, the foci of the standard type, that is x square by a square plus y square by b square, is plus minus ae 0. But in this case, my a is 3 and e I have obtained 1 by root 2. So ae is 3 by root 2. But if my center is shifted to 1 comma minus 3, I have to just add these coordinates of center, x coordinate to this and y coordinate to this. So the foci of my this reduced ellipse is, I just add, that is the x coordinate is here 1 of center, plus minus ae is here 3 by root 2 as I have derived here, comma, just add the y coordinate of the center, that is minus 3. So I just add 0 plus minus 3, that is minus of 3. So this is my foci. Further, if I have to find equation of directrices, equation of directrix was this, but to obtain the equation of directrix of this reduced ellipse, I have to just replace, I just replace small x by capital X and just add the x coordinate here. So x coordinate is here 1, plus minus a is here 3 and e is here since 1 by, so my directrix, equation of directrix is here x equal to 1 plus minus 3 root 2. If I have to find the length of major axis, since this is the first type of ellipse where A is greater than B, so major axis length is here 2a, so that is here 2 times x coordinate, so that is 2 into 3, 6. And the length of minor axis is here 2b, so b is here 3 by root 2, so my minor axis is 2 into 3 by root 2 or 3 root 2. So these are my foci, directrices, major axis, minor axis. Just I have reduced this into the form x minus h whole square, y minus k whole square. Now further application is here. Now look, the eccentricity of the ellipse 9x square plus 5y square minus 18x minus 2y minus 16 equal to 0 is. As I told you, eccentricity is root of, just take the 1 minus, take the smaller denominator in numerator, so that is smaller coefficient of x square and y square is here 5, so take that in numerator, and the greater one, that is the coefficient of x square, take in denominator. So my eccentricity is here 9 minus 5 upon 9, that is root 4 by 9, that is 2 by 3. So here my answer is B option. Eccentricity of this ellipse is 2 by 3. Now one more shortcut. If you get a question that a ladder is lying against a wall or a rod is lying against a wall, and if you have to find the locus of midpoint of that rod, that means the path traced by this midpoint, then locus is always circle. But if you get a rod is lying against a wall or a ladder is lying against a wall, so diagram is like this, and if you have to find the locus of a point, any point on this rod or any point on this ladder, so this is any point, so in this case we will obtain an ellipse. So these are questions of locus. So if you have to find the locus of midpoint of the rod lying against a wall, then that is circle. If you have to find the locus of any point on the rod other than midpoint, then locus is always ellipse. And from the diagram, what I get, this point is known as A0 vertex. This is minus A0. This is here 0B and 0 minus B. But what I get from here, that this A is the distance of this point from y-axis. As you can see here, this distance is A. And how do we read this? This is what distance of this point from y-axis. So A is distance from y-axis. And what next? This B is what? Distance of this point from x-axis. So B is here distance from x-axis. And equation of ellipse is x square by a square y square by b square equal to 1. Here we need A and B. Now look how we apply these results. Now in this question, a rod of length 12 centimeter moves with its ends always touching the coordinate axis. That means diagram is somewhat like this. The equation of the locus of point P on the rod, this point P on the rod, which is 3 centimeter from the end in contact with x-axis. That means if suppose this point is A, so this distance is, AP distance is 3. And the total length of this rod is 12 centimeters. So if this distance from A is 3, then distance from B is, this total distance is 12. If I subtract 12 minus 3, so my BP comes out to be 9. Now as I know, the locus is ellipse and the path trace be like this. So I just write this point A0 and 0B. Since the point is tracing this path, so point comes here and that must follow the given condition. And according to the given condition, this 3 centimeter is distance from x-axis. That means B is what distance from x-axis A is 3. How do we read this? This is what distance of a point from x-axis. So since B is 3, so A is here distance from y-axis. So if this is 3, so in that case, this comes out to be 12 minus 3, that is 9. So my A is 3, so my B is 3 and A is 9. So locus, as I know, is an ellipse. So equation of an ellipse is here. X square by A square, since A square is 9, so this comes out to be 81. Y square by B square, since B square is here 3, so this comes out to be 9 equal to 1. So I hope you have gained a lot from this video. I'll catch you guys very soon with new video. So please subscribe my channel Method Wise. Thank you.